Hey guys, Joshua Peterson, Peterson Electric here today at a customer's place. They asked us to hook up a pump and wire it. Basically what this is, from what I learned, was a vane pump. And what it's going to do, it's designed to create suction. The rotation says right here that it goes counterclockwise. Okay, so that's what you're going to follow for your blades that are going to be cooling this. And we wired it up. This is actually just... This circuit says right here on a nameplate that it is going to be a three-phase pump, and on the three-phase pump it's going to state that I think it was 1700 RPM and it was 208 to 230 volt. There's a list right here and then a list right here for the motor. Well, I looked in article 430.40 250 430.250, and it talks about a three-phase squirrel cage pump, motor, as well as, I'm assuming it's close to the same as a vane. But this circuit right here is going to be rated at, in the code book, at 9 amps, and that's going to be your running current. So I put a meter on it. My inrush was about 26 for a split second, but then it started running at about 6 amps. The voltage in here is about 212, so a little bit higher voltage, a little less amperage. And this is just going to be a 4-prong, 30 amp, 250 volt rated, 3-phase NEMA L1530. It did have originally a 5-wire system with the center prong as a ground, but one of the legs, the L, wasn't being used. So this is going to be set up as an XYZ, black, red, blue, and then the ground. And it's a twist lock, so you can't mix it up because the ground is the part that you're protecting as a twist. And then in here, before we fired it up, we took off the housing for the start and stop. Our wires were crispy in here. I think this thing's got to be at least 15 years old. So we went ahead and recut this off the SO cord and pushed back our strain relief about 8 inches and got fresh wire. And then I wrapped it in some 3M tape. So here's the interesting thing. In school, we actually learned that to reverse a motor, you just change the outside, the black and the blue. Well, I kind of learned something really nice off of the guy here. He just switched the red and the blue, which is going to be your B and C phase. And so L1 is typically your black, L2 your red, and L3 your blue. Well, I tried switching just the black and the blue, and it actually wanted to push the other direction, which is not good on the motor. It wants to suck, not push. And so we were hearing air come out of this diaphragm with the air filter. But anyway, so we just swapped red and blue, and now we've got it in the right position. And we'll go ahead and turn it on. So this is a 3-horsepower motor. Its design is to suck air all the way back through as a vacuum for whatever position they're doing for work. I think they're working on some boards or whatever. But we did wire up in the past in Lafayette 80 horsepower Trevini pump, and that had its own true isolated transformer, as well as its own disconnect there. So this isn't nearly as much as amperage. I think that 80 horsepower, if I looked it up, it was 8 years ago, I don't know, it's probably somewhere in the neighborhood of about 150 amps. But this right here was only going to be about a 20 amp breaker on this. I did rate my wire at 125% because of the fact it could be running more than 3 hours. And then I did go through and clean up the air intake right here. I cleaned out all of this filter, cleaned out this armature, this filter as well, because it actually cools one side and pulls the other. And we went ahead and just got it all brushed off for them. But yeah, it should be good to go, and we've got our phases in the right placement. So again, we do these minor, smaller stuff for industrial like this, and give us a call. Thank you.